Hi, I'm Daniel Sweigel.
I'm Matthew Hines.
I'm Joe Ryan.
And I'm Ben Cahaly. We're a group of students in the Industrial and Manufacturing Systems Engineering Department at Iowa State University. For our fall 2022 capstone project, we worked with a sheet metal manufacturing company located in Iowa, and our project was focused around line balancing and cycle time reduction.
The primary objective of our project was to decrease the assembly cycle time for the models we worked with from the bottleneck time of 406 seconds to the target cycle time of 158 seconds.
We completed time studies by breaking down the assembly line into 5 stations. You can see the average cycle time for each station that we identified. There were 4 stations operating above the target cycle time of 158 seconds, and the bottleneck was identified as the packaging station. It had an average cycle time of 406 seconds, which was 226% above the target cycle time. We then recorded cycle times for the individual steps within the packaging operation and put them here in a Yamazumi chart. We found the 3 longest steps to be placing and taping the top half of the box, which took 82 seconds, placing the cardboard packaging on top of the unit, which took 81 seconds, and placing labels on outside of the box, which took 55 seconds. These times were then considered when we redesigned packaging components and created new standard operating procedures. To address the long time it took the operators to put the packaging on top of the unit, we created 3 new designs for packaging. As you can see, we have Model A, Model B, and we created a third option that used a die to cut a one-piece layer. This was quickly decided against due to the high cost of creating a new die. You can see both Model A and Model B create fewer components, and this opens up a pallet location in the packaging area.
Likely the most important solution we identified was implementing a standard operating procedure for the packaging process. We divided the process steps among 2 operators to have them working in parallel as much as possible. Through testing with this and the new packaging components, the process was more organized and the time was reduced to 168 seconds from 406. The next thing the team wanted to analyze was the movement of operators throughout the packaging process. With the station layout shown on the left, we used Simio simulation software to create spaghetti diagrams and track the distance that each operator moved to process each unit. The diagram on the right shows the current state with one operator in green lines and the other in orange. This spaghetti diagram shows the future state operator flow. You can see there is much less movement and congestion than the current state, and the 2 operators tend to stay in separate areas of the station. This future state flow accounts for the redesigned packaging components and the installation of our standard operating procedure that were previously shown. Here, the quantitative analysis of operator movement is shown. In the current state process, the 2 operators were moving an average of 524 feet for the packaging of each unit. In the future state, after implementation of our process changes, operators move an average of 245 feet, which is a 53% reduction in wasted walking time.
Shown on the left is the current state cycle times. On the right are the results of our line balancing, which can be seen with a 45% reduction of cycle times.
We worked with our company to create 8 visual aids that can be posted on both sides of the packaging station, 4 for one set of models and 4 for the other set. Each model is further divided into 2 visual aids for each SOP alternate, one for operator 1 and one for operator 2. Each operator's visual aid has the packaging components they are responsible for numbered and highlighted to avoid confusion. These visual aids can be displayed either as laminated sheets or on monitors, and there is another alternate to have the same visual aid for both operators with nothing highlighted. Based on the reduction in cycle time of the packaging station and the yearly demand of units, we've calculated a yearly labor savings of 4,400 minutes. Using 19 operators at a fully burdened labor rate of $60,000 per year, we found that our work has created a labor savings of $47,000 per year, which equals a 3-year net present value of $114,800.
We would like to thank Dr. Sly, the IMSC department, along with our company, for all their assistance this semester.